Network Programming with Chris Woodruff.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company empowering .NET teams to be self-sufficient and very successful with their projects. My architect forums are going strong. Signups for the next session are up. And if you lead a software team and are looking to collaborate with peer architect leaders, then go ahead and sign up at the link in the show notes. And if you're looking for Programming with Palermo, my video podcast, then just go ahead and search for it in any of the directories and you'll be able to find it. My guest today on the show is Chris Woodruff, or as his friends call him, Woody. He's a software developer and architect of over 25 years. He loves software engineering, especially allowing applications and services to communicate across networks and through web APIs. And he's been a Microsoft MVP in SQL Server, Data, and C# in the past, along with multiple years of being awarded the AWS Community Builder Award. Woody lives in Grand Rapids, Michigan, where he explores the many breweries in West Michigan and travels with his family. And he also is a longtime bourbon fan and loves hunting for whiskey bottles. And we'll include links to his LinkedIn and Twitter and website in the show notes. But Woody, welcome to the show. How are you, sir?
Good, Jeffrey. It's been, well, I saw you at KCDC.
That's right.
But before that, we hadn't seen each other in a while. So it's really good to catch up with you.
Yeah, it was a long time. We saw each other a lot for a good stretch of years with when the INETA Speakers Bureau was going strong, and there were all those events at all the different conferences. So,
and your parties throughout the years at conferences, back in the old days. So that's when I actually had hair, and you didn't have that little bit of gray hair that you have. So that goes back.
Well, yeah, we're firmly in the double decade club where the people, the new programmers coming into the industry weren't born when we started coding for work. But it's all good. Yeah. It's fun.
It is. You know what? It's good because you get new ideas and you get new people questioning what us old people did. And sometimes you even get pendulums that swing back and forth. So there's lots of ideas that younger people are coming up today, and you go, we kind of did that 25, 30 years ago. Like the big thing is RPCs, remote procedure calls. And people think there's some new whiz bang thing now, but we used to do them back in the 90s.
Yeah, it's just the transport and the data envelope format is just different.
Yeah, exactly. It's usually what we transport. So it used to be that we transported everything XML, and now it's pretty much JSON or some flavor of JSON. So
over SSL. Yeah, encrypted HTTP. Well, you've had so much experience with so many things, and for people who were just at the Kansas City Developers Conference, they saw you speak on running your .NET applications in AWS, and you've spoken on so many other topics over the years. But for the listeners who haven't, been introduced to you, what are the kind of back us up? What are some of the high points in your career that have kind of steered you to what you're working on today?
Yeah, so I won't go into very long in this, but I've basically done everything in my career. I've been a developer, I've been a consultant, I've been an architect, I've been a database developer. I've been a trainer. I've created training materials. I've been a developer evangelist, developer advocate. I've been a leader of engineers. So, yeah, and the highlight is all of it, because I didn't really have a plan going through my career. I just kind of found interesting things. Now I look back and I go, I wish I would have done this now, and I wish I would have done that, and to get into a different place. But we can't have regrets, and I can't change the past. So I just enjoy where I came from. But for me, I love creating experiences. And for me, network, like building the facilities for network connections is probably the thing that I enjoy the most. And I love like web APIs and REST APIs, but I just really love, and I'm fascinated by how things travel from one computer to another computer.
Mm-hmm. Yeah, there's a lot there. Now, I want to ask you about this book idea that you have, and you've decided to write a book or another book. Tell us about it and what the genesis of it was. You know, what you said, I need to write it, or there needs to be this book, and I need to write it because this is the problem that everybody needs to know the solution to.
Yeah. So I'll tell you the truth that I didn't say this before we got in here. I'm actually part of writing 2 books.
Oh, okay.
So
Nice.
I'll tell you the second one in a second. But the first one, it's network programming in C# 12 and .NET 8. So it's taking a look where we are and then including any things that are coming out in November with all the new releases.
Mm-hmm.
And how this came to be is, you and I mean, when people get to a certain stage in their career, if they have shown like a proficiency in things, they usually have publishers that come and ask them if they want to write a book. They have some ideas. And Pact, which is a nice publisher. I like their books. They
do a lot of stuff. Yeah.
Yeah, they do a lot of stuff. They've hit me up over the last few years over a number of different topics. Like one was data architecture in C#. And I didn't feel I had quite the level of expertise on that. And then they asked me for to write a book on, I love JetBrains IDEs, like JetBrains Writer is like my favorite .NET IDE. But JetBrains came out with this kind of like a Visual Studio Code, like a very basic IDE that can cover lots of different areas, and it's called Fleet. And Pact asked me to write that book, and I said no, because that's not even going to be baked for another year. But finally they came and they said, will you do a book on network programming in .NET? And I went, yeah, I would love to do that. And I've always been one that I've wanted to write a book. I know you don't make a whole lot of money anymore on books, but it's just the fact it would be nice to write a book and have my kids see me write a book. Yeah. All my kids are older. They're in college or almost out of high school. But yeah, and I just want to do it just to have it as a checkbox.
Gotcha.
Now, the second book is Ted Neward and I are writing a book on the patterns of developer relations.
Oh, nice.
So it's kind of like taking the idea, the pattern of the Gang of Four book, which is kind of the software development patterns. That was a book that a lot of the software design patterns came from. And they had a clear way of communicating those patterns. And we're going to use that written pattern to kind of describe all the different things that you can do in developer relations. Okay, all the way from blog post all the way to like product documentation and training. So yeah, but that one's going to be, there's about 4 of us working on that book. So it's not all me. So
gotcha.
Yeah.
It's going to be the Club of 4 book.
Yeah, it's going to be, another gang of 4 for DevRel, I guess. So,
Right.
But that one's a fun book too. But so look out next year sometime for both those books.
Yeah. So network programming with C#, give the scope for what that entails and why programmers everywhere need to know, this set of things and why they don't already know it.
Well, I mean, the thing why they need to know it is no one uses a computer that is isolated from any other computer anymore.
Mm-hmm.
Like when you and I were kids, yes, computers were isolated. They for the most part, they weren't connected to another computer through a network. Sometimes we would go to school and they might be, or if we had an old 200 baud modem but I couldn't afford that because I couldn't afford the long distance telephone bills. So, but now everything is connected. I mean, everything from our computers to our tablets to our phones, they run across different types of networks. And everyone should have some knowledge around how those networks work,
Mm-hmm.
how they behave, the underlying protocols and the underlying technologies around those. So like everyone on the internet, if you program on the internet, everyone doesn't have to understand HTTP, but it's a good thing to understand enough of it to program. Like Microsoft has abstracted a lot of the knowledge around HTTP and HTTPS away from the developers.
Mm-hmm.
But it's always good to know what's going on under the sheets. Just like for this book I'm writing, everyone needs to know a little bit about TCP/IP, which is the protocol, it's the technology that makes sure that your packets that go across the internet, one, get to where they need to go, and also get there in the order that they were sent.
Yeah.
Because people don't realize the where the internet came from. And the internet came from in the early 60s. The Department of Defense started ARPANET,
Mm-hmm.
and they wanted a network protocol. They wanted a network that they could use around the military that was that could be part of it could be taken out by a nuclear blast, and the rest of the network could still function. So imagine you have a spider web, and that's where the World Wide Web came from,
Mm-hmm.
and the spider web. And if you took out part of that spider web, there would still be a path that could connect, that should connect to points that still exists in that network. Now, maybe certain parts of that network are taken out by something like a nuclear blast. That was the original intent. And getting those packets to where they need to go in the order that they need to be in was important. And really, that's where the internet came from. And ARPANET kind of gave it out to universities, which started using it. And then the US government kind of let it become commercialized. And so Al Gore didn't create the internet, but I think he was one of those senators or representatives of the United States that said, we need to allow this technology to get into companies and citizens' hands.
They were one of the yes votes in Congress that gave it some funding.
Yes.
So you're right. TCP/IP, if you've entered the programming world in the last 10 years, you probably never had a class in any of formal education that even taught you. They just assumed, oh yeah, the internet's already here. This is how it works. But under the covers, like you got things retrying packets, and then wait a minute, hold on. What the heck is a packet?
Yeah. So a packet is, so when you are in a web browser and you're filling out an order, and that does a post.
An HTTP post.
That does an HTTP post, and it has a bunch of information, a bunch of data in the HTTP request body. Well, that whole request doesn't get sent in one big envelope. So TCP/IP, the underlying technology for all the internet, really breaks that down into small packets so that it can be transported. Because you have to remember, networks back in the 60s and 70s and 80s weren't as fast as they are today. Mm-hmm. And they had a lot of latency in them. And if you could break these into small packets and send them across, they could be sent quicker with the resiliency of TCP/IP, and they would get to the other place very quickly. So really, that is what's going on. Is most people they have a decent idea of HTTP, because they know the verbs, and they know there's gets and puts and posts and deletes and options and patches and all the verbs, and then they know the response codes like 404s and the 400s and the 200s and the 500s, and they may know a little bit about 300s, but they know that, but they don't really know the layer underneath. And I am geeky enough, and I am going to nerd out to try to explain this, that, and socket programming and all the different protocols, or not all, but a good number of protocols that people can use. So I'm going to talk about like UDP. I'm going to talk about WebSockets and WebRTC and MQTT. That's a protocol for Internet of Things, and webhooks and REST and message queues and HTTP. I'm going to try to. The book is going to kind of dig in and have real world examples for a lot of that. But we're also going to talk about like async. Because you have to have an understanding of async and await. Mm-hmm. Because when you send something across the network, you can't just be sitting there waiting for it to come back, because one, you don't know when it's going to come back. So you can't really keep all those resources locked up. Right. We all programmed like that 20, 25 years ago, and it was a horrible experience. And also I'm going to talk about like how to test it and how to deploy it and how to kind of the data that's serialized in mostly the HTTP bodies, how those can be serialized and encrypted and back and forth. Yeah. So it's a general overview of network programming. So other people have done it. I'm just going to do my take on it.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo.
Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Yeah, as you were listening those out, it reminded me a lot of web programmers, they have access to the language of HTTP because the modern browser dev tools, when you hit F12, it kind of puts those front and center. You can look at the actual implementation of the HTTP protocol, but unless we're using Wireshark or a network sniffer, we don't have any kind of visualizer for how transfer control protocol takes the HTTP request and starts breaking it up before sending it over the wire.
Yeah.
That's interesting.
Yeah.
And all these other ways that an application can talk to another application, all the different choices. Whereas, unless we really look at them, we might think, oh, web service here, web service there, everything's a web service.
Well, and if you take a look at the history of web services, really, they all started out, I mean, they were all pretty much RPCs back in the, I'll say back in the 90s.
Binary calls or binary information, right?
Yeah. Yeah. Binary information. And then this thing called SOAP. It's
WSDL and WS star.
WSDL and WS dash star and all that. I didn't really enjoy that part of the networking experience because I thought it was a little too rigid, but it was what it was and it met a need.
Mm-hmm.
So we had that. And then we moved into, I call it calls over HTTP because there wasn't really a standard way of doing it. And
wasn't it a revolt against SOAP? SOAP was like so much overhead that programmers just said, to heck with it. I'm just gonna send some text in whatever format over a straight HTTP call.
Exactly. And if people remember the first APIs that like Twitter and Facebook released, I want to say those were probably 2008 to 2010. A lot of those were, you had to actually read the manual, read documentation to understand what you had to send over, what you got back, what verbs you had to use, because some of those old APIs, everything was a post.
Mm-hmm.
Like if you wanted to insert data, sure, that's a post. Yeah. But if you wanted to get data, that was a post. It just had different, either it had different header, HTTP headers, or it had maybe some something in the body that described the way that the data or the request was going to be. So it was really strange. So everyone had their own way of doing it, and you had to read the documentation, and it was tough.
Mm-hmm.
And then we have Roy Fielding. People started reading his dissertation.
Well, you gotta tell us, who is Roy Fielding?
So Roy Fielding was a very smart guy, and he wrote a dissertation on I don't know if this, I'm maybe not getting 100% correct, but he wrote a dissertation for his PhD on the architecture of the internet.
Okay.
And it talked about like lots of different things like leveraging. On the internet, you don't need to recreate. You don't have to recreate everything from the ground up. And that's what all of these like Twitter and Facebook and all these Web 2.0 companies were doing. They were just recreating these APIs from the ground up.
Mm-hmm.
And Fielding said, you know what? Use the behavior and use the constructs of the underlying technology to to build your architecture on the internet. And really that meant looking at HTTP and saying, if I want to receive a resource from someplace else, I use a GET.
Mm-hmm.
If I want to insert a new resource someplace, and the resource could be anything. It could be an image. It's anything that can be transported across the internet. When I say resource,
mm-hmm.
then that's a post. And if I want to update it or change it, that's a put. And if I want to delete it, that's a delete verb. And then he took one step further and created this idea of the 6 constructs that he thought should be used to create what we call REST, representational
state
transfer protocol, or transfer standard. I don't know. So
I thought it was
REST.
state transfer. It's been a long time.
State transfer. You're right. Representational state transfer.
Yeah, we ended using acronyms from time to time and forget what they actually stand
for. You forget what they actually stand for sometimes.
Is put a word or is put an acronym?
A put is a verb. Well, PUT it's an HTTP verb.
Right. I was just wondering if it was an actually acronym originally. Go ahead.
No, I don't think so. It's just a verb that came from the HTTP standard body. So
Royal Fielding is the author or the originator of the concept of REST, or the way of thinking of it.
Yeah. And he has 6 constructs. I'm not going to go into them, but you can look them up. I do a talk just on REST
mm-hmm.
and HTTP. So I am pure geek when it comes to this. Like, no one thinks that anyone can talk for an hour or two on all this. I probably can. So I enjoy talking about it. But it's this idea that you know what, we have these frameworks and these libraries that do abstract a lot away from us. Sometimes that's a blessing and sometimes it's a curse,
mm-hmm.
because you're living with those constraints, or that the framework authors have put in front of you.
Mm-hmm.
And the people that have created the old .NET framework, and now .NET Core, and now just .NET, have done a good job. But sometimes you do need to drop down and get deeper into the weeds and to understand a little bit more.
So give us some examples. You're writing this as a network programming for C# and .NET 8. But besides just the web service, HTTP client and that type of thing, what are some other examples where instead of reaching for HTTP client, you would in C# do call out to a different application a different way?
Sure. So UDP, which is really a streaming protocol,
mm-hmm.
doesn't use isn't really in the same vein as HTTP. There is a way that you can have HTTP where you open up like a connection that's open continuously. But
mm-hmm.
so UDP is this way that was created to stream information. So stream like audio and video and stuff like that. You have just WebSockets, so you can open up a WebSocket between as long as the two sides understand each other, they know mm-hmm. how to communicate. That kind of is a really simple way to just connect two endpoints, and it doesn't even have to be like a computer to a traditional computer. It can be like in the cloud too. So you can do a lot of this stuff up in Azure and AWS and a lot of the cloud infrastructures, and all those cloud infrastructure, each one of those cloud platforms, they use a lot of this stuff too, because if there's like Azure and AWS may have media streaming, that's probably UDP underneath. So by learning this, you also understand a little bit more. I'm going to turn it back to cloud because that's what your podcast is. You understand a little bit of the underlying technologies with cloud also.
Yeah. You mentioned WebSocket, and the Azure SignalR service is just one big WebSocket service, which I think WebSockets are typically hard to scale anyway. And so it's great that Azure has it set up for us where we can just throw a little bit of code up there and it just works. And now we have applications that just have a persistent WebSocket, kind of WebSocket broker. And then we have, server originated backend to multi front end notification real time. That's pretty cool.
Yeah. And then you jump over into these like sub pub and message queues and I mean, traditionally, like if people know like Kafka is a product or a feature. It started out in AWS, but now you can do Kafka in many different places, but you have RabbitMQ. That's a big .NET message queue technology. I'm really fascinated by Dapr, DAPR, the Dapr project, which lets you build like building blocks that allow you to connect different network resources together, like local and cloud across all the cloud platforms. That's an interesting. So in the end, you have to know network. You have to know something about the network that we use to be a good developer, I feel.
Yeah. So is there any topics in your book that you have planned? I don't even, if you have your whole table of contents laid out already, or if you're still working on it, that gets into routing and firewalls, or is it purely C# visible capabilities?
It's more C# visible. Like I do have a chapter that's gonna touch on common security threats. There will be a little bit on encryption, but I'm not going to really go into the things like firewalls and proxies and which are important to the network topologies that we build these applications on. But I've got all the chapters worked out, but I don't have all the guts of each chapter worked out. So I mean, when you test and debug your network, you may, because maybe you're hitting an Azure implementation of like a web API, and you may be hitting behind a proxy. There may be 10 instances of that web API, and how you develop that web API. Let's take caching as an example. Like a simple way to cache is just put caching into your, like in-memory caching inside your web API, inside the actual .NET project and the .NET solution, and let your .NET application do that. But by running that across multiple instances in Azure or any of the cloud platforms, that's going to cause a lot of problems, because if I have 2 and I cache information over here and I cache other information over here, they can't share their caches.
It's siloed.
So that's why we have memcache and we have distributed caching that exists on all of the cloud platforms,
Mm-hmm.
as well as if you have a local instance of your web API or your network application. You have things like SQL Server distributed caching. You have Memcache that you can run locally in your server farm or your local web servers.
Yeah.
So that you have to understand that too. You have to understand caching. So there's just a lot of stuff that you have to know about the transport across the network, as well as how to build the code and architect your application so that it utilizes the network efficiently also.
Yeah. As much as securing applications is important and there's always attacks going on, what came to mind was how some online services have started charging for the rate of use of some of their web services, and that's at a protocol level higher than TCP, higher than HTTP. There's no way that could be baked into a router, because the information to know whether or not someone's gone over their quota and they should be blocked, that's not an HTTP concept. And so that has to be somewhere in the code that's implementing or on top of HTTP to read a little bit, identify, maybe go check a database and say, oh, I shouldn't allow this call to proceed. Yeah. And now it's almost like it's a protocol that we sometimes have to develop on top of HTTP in order to bake in those functionalities, but ahead of the web service controller that would otherwise just service the call.
Exactly. Yeah, and we see a lot of that when we do what you're saying, like rate limiting. Mm-hmm. Yes, you can build that into your .NET application, or Azure and AWS actually have the ability to take care of that also at the proxy level. So you can actually set up rate limiting before it gets to your HTTP service endpoint. But think about authentication, authorization. I mean, that's something that we have to build. That's not part of HTTP. That has to be built on top, and we have JWT, which is JavaScript web tokens. Yeah. So that's the ability for a web client, some kind of mobile app or web app, to be able to use a web API, because remember, our network, the entire internet, is stateless. So the server doesn't know that I'm logged into a web app or a mobile app. Mm-hmm. Each time I do a call, I have to send over this JWT, this token, and then the other side has to say, hey, is this token valid? Is this token correct? If it is correct, what is the authenticate, or what is the authorization level that this client have? Mm-hmm. Like maybe the JWT, the token, says I can get data, but I can't insert data, I can't update data, and I definitely can't delete data. Yeah. And then another token, which describes a different user on our client side, maybe has full admin rights. So, but that's up at the application level, the application layer. And there's lots of stuff at that layer that we have to either develop by hand or use a cloud feature, or use a third-party feature. Like if you're going to do authentication authorization, I would suggest that you use Okta or Auth0, or if you're going to use cloud, Azure AD, And on AWS, it's identity. It's like they have an identity service, or you can use like identity server if you're going to do it and you have a local, like if you want to do it locally.
So when do you have a target publish date for the book? Or are you that far along?
It'll probably be coming out next May, May or June. Yeah. So I think I have
10
to,
months.
let me look at my schedule. I have to get everything wrapped up by the beginning of April 2024.
All right, that's going to come forward.
And then it takes a while for the books to actually get published. So I'm probably looking at sometime in May of next year.
Very cool. Very cool. Well, we'll look forward to it. I think it'll be a good book, and one everybody needs to know this stuff. I mean, and we have so many new programmers in the industry, which is great. But yeah, some of this foundational stuff, it's easier to learn it than to accidentally make some mistakes and then realize, oh wait, there's like a few stacks of protocols that's going on here. So
exactly.
Well, Woody, thanks for coming on the Azure DevOps podcast and sharing with us about network programming. That'll be a good read.
No problem. I hope it fit into the whole kind of Azure, because it is important, and
it is
using the cloud. You have to know about networking, because the cloud is just some other computer out there. So, right?
That's right.
Yeah,
that's right. Microsoft is making a lot of money selling us compute cycles with memory attached.
Exactly. So, yep.
All right.
And I appreciate you having me on too, Jeffrey.
Oh, my pleasure. My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.